Okay, so in our last set of notes, we made we created equivalent ratios, and we did talk about how it's very much like equivalent fractions. Okay, and when we scale, we are either multiplying to scale up or dividing to scale down. Okay, and it's the same thing with creating equivalent fractions as well. Okay, and we're always working with factors. Factors are numbers we multiply, factors of both of our numerator and denominator in our ratio table. So equivalent ratio, excuse me. However, a ratio. Today we are focusing on ratio tables, and I know I kind of introduced that a little bit in the previous notes to make connections. We know that equivalent ratios can be organized in a ratio table. Give two equivalent ratios in the table below. So one thing I want to point out, because our ratio is boys to girls, is that this is a simplified ratio because my numerator and denominator, the greatest common factor, is 1. So to create an equivalent ratio in my table, I must multiply. I'm going to scale by multiplying by the same factor. I know in my last notes we talked about multiplying by 2 each time. So from 2 to here, 5 to here. I multiply by 2, okay, I get 4. And then 5 times 2 is 10. Okay, and then if I do it again, 4 times 2, I get 8. 10 times 2, I get 20. And the premise is, when we did this on our last notes with our calculator, is to determine if they are equivalent. If we were to simplify our ratios, they would all simplify down to 2 to 5. Okay, 2 to 5. So let's look at this table right here. So we're going to do the same thing, complete each table with 2 equivalent ratios. So again, 8 to 3, this is simplified because the greatest common factor of 8 and 3 is 1. And so 8 times 2 is 16. 3 times 2 is 6. And then 16 times 2 is 32. 6 times 2 is 12. And if you were to simplify the 2, I'm going to remind you guys of this, because in my first column I have 8, so it would be 8 to 3. So as a fraction, it would look like this. Okay, 8 to 3 right there. And so if I were to simplify 16 to 6, so what I'm going to do, remember, is I'm going to put second and make an improper fraction to demonstrate my ratio again. So it does simplify to 8 to 3. Okay, but let's look at number 2. Number 2, we have 24 to 150. So this kind of shows me right here that I could scale down and I can scale up. And so I want to divide by a common factor. Now in this case, you don't have to divide by the greatest common factor. You can divide by 2 if you want, because 2 is a common factor of 24 and 150. So 24 divided by 2 is 12. 150 divided by 2 is 75. And then if I want to scale up, I can again multiply by 2. 24 times 2 is 48. 150 times 2 is 300. Okay. Number 3, find the missing values in our ratio tables. We have a lot of examples of things that can be thrown at you. So let's look at this. So 3 to 7. So this time I have my ratio 3 to 7. We know this is a simplified ratio because the greatest common factor is 1. And so I've got to ask myself, what happened from 3 to 9? How did I get from 3 to 9? What did I scale? Remember, we cannot add or subtract. We are only multiplying or dividing when we scale with ratios. I know that I'm increasing, so I must multiply. And so I know that 9 divided by 3 is 3. So 3 times 3 is 9. So whatever I do to this side, I have to do to this side. So 7 times 3 is 21. That's the thing about scaling, is that to continue to make it an equivalent ratio, you must scale by the same number, either multiplying or dividing. And so this time I'm going to ask myself, how did I get from 3 to 24? Well, 24 divided by 3 is 8, so 7 times 8 is 56. Okay. Next one, roses and carnations. I'm looking for a complete ratio. I have 8 to 12 right here. So I need to ask myself, how did I get from 8 to 2? And now I'm going backward. I'm scaling down, so I divide by 4. So 12 divided by 4 is 3. Okay, now watch this. I'm going to go from my simplified ratio, and I'm going to ask myself, well, how do you get from 3 to 60? I can multiply by 20. So 2 times 20 is 40. There are many ways we can look at these, okay? Just giving examples. So number 5 says 12 to 144. That's my ratio. How did I get from 12 to 4? Well, I divided by 3. So now with my calculator, I'm going to do 144 divided by 3, and I get 48. Okay. And then I'm going to ask myself, well, over here, I will say we did go from 3 to 60. You could also have done 12 to 60. So this time I'm going to ask myself, how do I get from 144 to 432? That's where I got to divide. 432 divided by 144. 3. I multiplied by 3. So then I would have to do the same from 12 down here to make it equivalent. So 12 times 3 is 36. Okay. And then I have 15 ounces of lemonade to 24 ounces of tea. So how did I get, I'm going to go backward, from 12 to 24? Well, I divided by 2. Ew, we don't like that, because it's not going to be even, it's going to be a rational number. Ew. 15 divided by 2 is 7.5. You can have 7.5 ounces, it's okay. And then how do I get from 15 to 75? Well, from here I multiply by 3. No, I didn't. I think I multiplied by 5. Can you believe I just did that? Woohoo! Multiply by 5. So 24 times 5. I get 120 ounces. Okay. Oh, feet to seconds. I have 60 to 25. So how did I scale down to from 60 to 15? If I'm not sure, I'm going to divide. 60 divided by 15, and I divided by 4. So now I need to do 25 divided by 4. And I get 6.25 seconds. Okay. And then I've got to figure out, well, how did I get from 25 to 5? I like that better. 25 to 5, I divided by 5. So now I'm going to do 60 divided by 5. And I get 12. Okay. My last one. Pounds to cost, 4.5 pounds to $10. Okay, so I'm going to ask myself, though, how did I get from 4.5 to 9? Remember, well, I am scaling up, but I can only multiply. So I'm going to say 9 divided by 4.5, and I get 2. So 9 divided, so I divided by, or I can multiply. So 4.5 to 9, I said times 2. 10 times 2 is 20. Okay. So how did I go from $10? No. I'm going to go 20 to 50. 20 to 50. 50 divided by 20, and I got 2.5. I got 2.5. Okay, so I multiplied by 2.5, and then I'm going to go 9 times 2.5. I get 22.5 pounds. And again, as you're creating these tables, you can always simplify. You can always simplify, okay? I mean, to check your ratios. Sorry, it's early, friends. It's early in the morning. I don't think it's even 7 o'clock yet. Oh, nope. Okay. All right, so here is a real-world situation, graphing ratios. Now remember, we did graphing tables in topic 4. So we're just taking this up a notch. So the pizzeria credits Remy's account $3 for every 5 pizzas she orders. Sounds like Domino's. Complete the ratio table below, then graph the ratio. So for each pizza, every 5 pizzas, she gets $3 credit, 5 to 3. So what did I do to go from 5 to 10? Well, I multiplied by 2. 3 times 2 is $6. Okay. And then how did I go from 10 to 20? Well, I multiplied by 2. So I have $12. Okay. And then we'll say, because I like whole numbers, how did I get from 5 to 25? Well, I multiplied by 5, and I have $15. Please also note the change, right? It's an even change. It's an equivalent change, okay? So now, this is where we talk about, bring back those independent and dependent variables. So this is my Y. I'm labeling my table or my graph. And this kind of helps you visualize and understand. Now, we have to know what our independent variable is. And kind of here in our table, kind of, this would be my X, this would be my Y. So my independent variable is the pizzas because I don't know what my credit would be until I order pizza, okay? And this is my credit. And you can, if you want, you have to label. So I'm going to go 0, 5, 10, 15, 20, 25. It's super tiny. I'm going to go 3, 6, 9, 12, 15. Okay. So I'm graphing it. I'm going over 5 up 3, over 10 up 6. It's only 7 o'clock. Over 20 up 12, over 25 up 15. Okay. And it should be linear, meaning I could draw a straight line through all of my points because they are all equivalent. So how much credit will she have after 15 pizzas? So as you can see, there's kind of a hole there, right? And if I'm following my pattern, I just drew my line here, 15, I should have 9. I should have $9. But Miss Collins, what if I'm not sure? Well, you just come on over here. And you now have 15, right? I have 15 pizzas. Well, I'm going to put in my simplified, my first ratio. How did I get from 5 to 15? Well, I multiplied by 3. So 3 times 3 is $9. You could do that as well. And then another question is, how much credit would she have after ordering 15 pizzas? Okay. Well, if I'm going to go, 40 pizzas. So this time, 40 pizzas. I'm going to just add 40 here to the bottom. Okay. And so how do I go from 5 to 40, right? Well, I multiply by 8. So 3 times 8 is 24. 24. You don't have to graph that. Okay. $24. It pays to order pizza, doesn't it? All right. So now we're going to use the given information to complete a ratio table, then graph the relationship. So the ratio of teachers to children at preschool is 2 to 15. Okay, is 2 to 15. So I've got to ask myself, how did I get from 2 to 15? 2 to 15. All right, so 15 divided by 2 is 7.5. So I multiply by 7.5. Well, if I have 3 teachers, let's say 4 teachers and 5 teachers, okay? So realistically, yeah, I would multiply by 7.5. And that would give me 22.5 children. I know, that seems weird. We don't cut kids in half. So in the real world, friends, you'd have to bump that down to 22. And then 4 times 7.5, 30. And then 5 times 7.5, 37.5. And then you would go again. Teachers, kids. And so I'm going to just do like we did 2, 3, 4, 5, and then kids. 15, we'll say 20, 25, 30, 35, 40. Yeah, we have got to do all the things. As you can see, it's okay if it's not exactly on an intersecting point. They will be linear though. 37.5, just like that. Okay? So, if you are not with us, I'm going to ask you to do 10 and 11 on your own. If you're with us, we'll do them together in class, but I would like you to have some independent practice to show me that you understand when you come back.